Binomial theorem. Binomial theorem gives a general method for expanding expressions of the form a plus b raised to power n, like we can see on the screen. A plus b standing alone is what we refer to as binomial, from the word bi, an expression having just two terms. And so everything we'll be discussing on this topic works for only binomials. So a binomial expression is an algebraic expression containing two terms, like I just said, such as these examples here. And take note, for the power, this exponent, this index number n, it is always a positive integer for now. We'll see cases where n can be a negative integer or a rational number. The binomial expansion is this that we have on the screen. That is, a plus b raised to power n is n combination 0 times a raised to power n plus n combination 1 times a raised to power n minus 1 times b plus n combination 2 times a raised to power n minus 2 times b raised to power 2 plus we keep going on following the same pattern till we get to the second to the last term, which is n combination n minus 1 times a times b raised to power n minus 1 plus n combination n times b raised to power n. This binomial expansion can be summarized this way as a plus b raised to power n equals the summation from r equals 0 to n for n combination r, a, and raised to power n minus r, b raised to power r. Now take note that the coefficients of our terms in the expansion are these combinations: the n combination 0, n combination 1, n combination 2, and so on. And when we see an example, we'll be able to study some patterns in this binomial expansion that makes it easy for us to understand. The binomial theorem is like a pattern, like I just said, or formula machine that helps us expand powers without multiplying brackets repeatedly. If you have a plus b raised to power 3, for instance, it means you have to expand a plus b in 3 brackets, whereas you can only take 2 brackets at a time, and so it becomes very complex. And that's why the binomial expansion helps us to do such expansions, especially for large n, more easily. Right now, this is the formula, the summarized formula that we saw earlier. And when the sign, the operation sign in our binomial is minus, this is the formula as well. Important points in the expansion: the expansion has n plus 1 terms. That is, if n is 2, for instance, the final expansion we have 3 terms. That's 2 plus 1. And then the power of a decreases from n to 0. If we check here, see, the power of a starts with n and it keeps decreasing: n minus 1, n minus 2, The next one will be n minus 3. You keep going down, 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 up to this term. Here you see the power of a is 0. That's why it's not appearing. A raised to power 0 is 1. And conversely, the power of b increases from 0 to n. There is b here, but it's raised to power 0. B raised to power 0 is 1. That's why it's not appearing. Then we have b raised to power 1, b raised to power 2. The next one will be b raised to power 3, and keep going. We'll have b raised to power the number before n and b raised to power n. And then another pattern to observe is the coefficients of our binomial. This is supposed to be the combinations, right? The combinations are the binomial coefficients, right? Like we said earlier, these n combination 0, n combination 1, and so on. The r plus 1 term of the expansion of a plus b raised to power n is given with this formula. What is the difference between this and this? We shall see later on. There's something we call the Pascal's triangle, which can give us the values of these combinations that are the coefficients in the terms of our expansions. The Pascal triangle can give us those values easily. How is the Pascal triangle constructed? We have 1, 1, 1. Then we start summing. 1 plus 1 will give us this 2, right? And then we'll begin with 1, end with 1. We'll begin with 1 again on the next line, end with 1. But for the middle terms, we'll sum 1 plus 2, 3. 2 plus 1, 3. Begin with 1, end with 1 again. The middle terms, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. We can keep going. Go to the next one. Will be 1, 5, 10, 10, 5, 1, and so on. Now, each of those rows for our Pascal triangle represent the value for the combination for the terms. For example, when a plus b is raised to power 0, of course anything raised to power 0 is 1. That's why our first row in our Pascal triangle is just 1. Now when a plus b is raised to power 1, we're saying we're going to have two terms, because 1 is our n now, and we said our expansion always has n plus 1 terms. So the two terms, we're saying the coefficients that will be present in those two terms should be 1, right, multiplied by whatever variables are attached. Also, in the case of where n is 2, the combinations will be 1, 2, and 1 that will attach to the three terms. We'll have three terms, 2 plus 1 terms, right? For example, we have x plus y raised to power 5. From Pascal triangle, when n is 5, we'll have 1, 5, 10, 10, 5, 1. So we know we must have 6 terms for this expansion. Then we'll go ahead to apply the formula, and we'll get a solution, right? Let's see a full example that shows our expansion like this. X plus 2 raised to power 3. X plus 2 raised to power 3. If we check the points where n is 3, because our n is 3 in this example, for our Pascal triangle, when n is 3, the coefficients are 1, 3, 3, 1. And as you can see, 1, 3, 3, 1 are appearing on the terms in our expansion. They are gotten from these combinations. 3 combination 0 must be 1, 3 combination 1 must be 3, 3 combination 2 must be 3, and 3 combination 3 must be 1. That's what we are saying that the Pascal triangle helps us to do. Then other parts of the formula will be attached. Our formula is n combination 0 a raised to power n. Our n is 3. Our a in this case is x. Our b is 2, right? So x raised to power 3 will be on the first term. Then 3 combination 1 x raised to power 2, because our power for x will be reducing while the one for 2 will be increasing. We have 2 raised to power 0 here. 2 raised to power 1 is now appearing 2, right? Then plus the next term, 3 combination 2. Power for x will reduce again. That will be now 1, x raised to power 1. Power for 2 will increase from 2 raised to power 1 to 2 raised to power 2. And finally, on the last term, we'll have 3 combination 3, and then 2 power for 2 increase, 2 raised to power 3. Power for x will reduce, x raised to power 0, which is 1, right? So we have this second line will be 1 from the combination from Pascal triangle, x cubed plus 3 into x squared times 2 as well, plus 3 times x times 4 from 2 raised to power 2 is 4, plus 1 times 2 raised to power 3, which is 8. We'll solve all that. We have x cubed plus 6x squared plus 12x plus 8. And that's our expansion for x plus 2 raised to power 3. We have a similar example here. In this example, we'll have minus in our binomial. It's the same procedure. So to solve 2x minus y all raised to power 4, n is 4. And so the coefficients from our Pascal triangle will be 1, 4, 6, 4, 1, right? Those coefficients help us solve all these combinations easily. And so our expansion 2x minus y all raised to power 4 will be this. The only difference here is we're including the minus y, and the minus is very important because it will alternate the signs at the end of the day. And so in this case, our 2x is a and minus y is b, n is 4. So remember, powers of a will decrease. A is 2x, so from 4 to 3 to 2 to 1 and 0 here. And powers of b is minus y, would increase from 0 to 1 to 2, 3, 4, right? And of course our combinations will just be 4 combination 0, 4 combination 1, combination 2, combination 3, combination 4. That's how it goes. So when we do this, when we further expand, we have 1 for 4 combination 0. Pascal triangle has told us that, so we don't need to be solving the combination. That's what the Pascal triangle does. It saves us the stress of solving all these combinations. So for combination, 0 is 1, 2x raised to power 4 will be 2 raised to power 4, which is 16, and then x raised to power 4. Take note. Plus, we have for combination 1, which will be 4, and then 2 raised to power 3, 8, x raised to power 3, and then we'll multiply all that by minus y. We'll move to the next term. For combination 2 will be 6, 2 raised to power 2, 4, x raised to power 2, then minus y raised to power 2 is the same as sorry, there's supposed to be minus here, although it will still become plus at the end of the day, because minus y squared is still y squared, right? Minus y squared is the same thing as minus 1y squared. So the minus 1 we take square. Minus 1 square is 1, and then y squared, right? So but this, there's still supposed to be okay, yeah, that's what they've done already, because the square is now with the y. That's why the minus is no more appearing here. Then to the next one, for combination 3 is 4, and then 2x, the power of 2x reduces to 1, and then minus y cube, right? Now it's minus 1 cube, then y cube. Minus 1 cube is minus 1, and then y cube, right? Then plus 4 combination 4 is 1, minus y raised to power 4 will be minus 1 raised to power 4, which is plus 1, and then y raised to power 4. So 16x raised to power 4 minus 4 times 8 is 32, x cubed, then y. That minus is coming from this minus y, so it changes this to minus, changes this plus to minus, then plus 6 times 4 is 24, x squared, y squared, minus from this minus 8xy cubed, and finally plus y raised to power 4, right? So I have another example. A plus 1 over b all cube, right? So in this case our a is a, but our b is now 1 over b, right? Our n is 3. So the same procedure, powers of a will descend from 3 to 1, 0, and then powers of 1 over b will increase from 0 to 3. 0 here, 1 here, 2, and 3. So do all that. Our Pascal triangle will be 1, 3, 3, 1, right? Follow all the expansion, and we'll have this a cube, 3 from our combination 3, a squared, 1 over b. Next we have 3 again, a, then 1 square over b square. 1 square is 1, b square, right? And then 3 combination 3 is 1, and then 1 cube over b cube. Take note, I said 1 cube, yeah, so I said 1 square. So in case it's not 1, the number will change. Let's say it was 2 over b, for instance. You have 2 square, which will be 4 over b square. If it was 2, it will be 2 cube, which is 8 over b cube. So because it's 1, it still remains the same. So this finally is a cube plus 30 square over b plus 3a square over b plus 3a over b square plus 1 over b cube. The next example is also similar to the ones we've been solving. So I'll continue from approximation in the next video.